Hello everyone, my name is Maxim Demchenko. I am from Security IP business of Rambus. I'm technical director responsible for MACsec and IPsec line rate silicon IPs. This presentation will cover convergence of MACsec and IPsec functionality in data center silicon designs. It will explain how we address the requirements, which solutions we provide, and how the market is adopting this technology. Let's start with an overview. Data centers continue to adopt full line rate security at various levels and use cases. Layer 2, which is MACsec, and Layer 3 IPsec security protocols are used to protect either full links or specific subnets or even customer-driven virtual networks. The integration of multiple security protocols is becoming an important requirement for data center silicons that aim to support multiple use cases and make use of network security to be more cost efficient. This presentation describes the use cases and Rambus solution for adding MACsec and IPsec into data center silicon designs in efficient and cost-effective way. The trends for using network security in data centers is the following: that network security is becoming a must these days for protecting sensitive and valuable data, to protect infrastructure and its operation, and separating provider-managed security from user-managed security, obviously where possible. But security adds cost. It adds silicon cost, which ended up in hardware cost. It adds additional power, it means operating cost, and it has administration overheads with setting up, managing, monitoring. Therefore, data center data in motion security must be smartly applied, meaning that it really needs to be applied where possible and in universal way. So it should be modular, means added or enabled only where needed, flexibly featured to address various needs without growing nomenclature of the devices, and interoperable where possible, allowing sources, the equipment, and software from different vendors. Implementation of network security in data center can vary depending on use cases. It can be based on physical location, which means local, like server to top of the rack switch or rack to rack. It can be in between data centers towards the provider networks, across the provider network, and external towards the enterprise campus, edge devices, mobile base stations, and individual clients. Another way of applying network security is based on logical use. It means that virtual machine to virtual machine, and even protecting the customer virtual networks, which are based on like VLAN, MPLS, and VXLAN. The usage of secure protocols, it is MACsec, which is either standard MACsec or extended feature set, allowing to apply it across provider bridges, across virtual machines. And similarly, IPsec ESP protocol used as a subset of features and possibly with few extensions. Let's look to network security protocol as MACsec. So MACsec was originally aimed as point-to-point or point-to-point layer security. In data center, it's also being adopted to protect layer 2 packets carried over tunneling protocols like MPLS, VXLAN, etc. In the given diagrams showing how standard MACsec is usually applied to protect layer 2 packets, with having VLANs without being in clear and VLANs in clear, which allows them to traverse certain type of network equipment. Extended use of MACsec means that MACsec is applied for example, Ethernet over MPLS. It still remains standard MACsec transform, but the engine which implements that would need to take into account presence of MPLS stack and skip it and apply MACsec to inner layer protocol. This use case allows to protect communication across MPLS switch network. As an alternative to MACsec, we can look to IPsec. IPsec was originally meant to be deeply integrated into the system and has many options defined. Data center use cases require line rate and area-efficient implementation. Therefore, a subset of features is selected along with high-speed ISGCM cipher. IPsec is applied to protect IP protocol level, which means IP headers, IP payload, but also can be combined with protocols like VXLAN and when IP packets are carried over MPLS stack. Here, the pictures show IPsec tunnel mode transform, which is the mostly used because it allows to protect IP header to hide it from inspection and use outer IP header to set up a tunnel between the points which talk in secure way. Alternative way is to use transport mode. And in transport mode, it means that only the payload is protected and IP header remains like that. But payload can be protected and replaced with, for example, UDP header, which can pass different types of equipment. If we look to data center silicon devices in high performance environment, we can see the distinct architectures where there is a clear possibility to apply network security. Typical type of devices in the data center are switches, routers, server or compute farms, and network attached storage, which is flash devices or traditional HDDs. In each of these type of equipment, you have the core ASICs, which is either switch ASIC, CPU, or GPU, and flash controllers. They are connected to the external network, usually through the Ethernet switch, Ethernet PHYs, or directly to the optical module, which also has its own PHY. So as you can see, for example, adding security can be easily done by installing Ethernet PHY, which supports network security, or having an optical PHY with ASIC, which can support security as well. So this is a typical way of using security in the system, which will be discussed in the next slides. So how network security is practically implemented in silicon devices. So PHY ASICs are the primary choice for integrating network security. And the primary reasons are that they have less constraints on silicon area and power than larger switching and DPU ASICs. They have shorter design and deployment paths compared to more complex ASICs. It means that there can be more variants added later. PHY ASICs with security are placed into line cards, and vendors can order and install line cards with security on a need basis. PHY ASICs with security may also be integrated into pluggable modules, either optical or copper pluggable modules. And what is important that open source software does support security in the PHY ASIC through switch abstraction layer. Another way to add security is to add it to switch ASICs, and there are trends on the market to have it, but so far the trend is primarily for enterprise 5G targeted devices, which still have room to add that kind of capability in their silicon and power budget. Smart NICs DPUs are getting more popular to offload various networking tasks from the system, and they also integrate network security either deeply into the data flow or as part of the Ethernet subsystem. Alternatively, they also may get security via just onboard PHY. So it means that smart NIC card will get just PHY similar like switch LAN card has. Now let's talk what Rambus offers in this space and how it can be adopted to support data center security. Rambus has been providing IPsec capable silicon IP for over 20 years. So we have a lot of products which support IPsec and MACsec or combination of those, and they have been applied in different markets, applications, and type of devices. The currently active portfolio includes look-aside multi-protocol accelerators for IPsec, TLS, DTLS, and basic crypto transforms, look-aside and inline multi-protocol accelerators with specification allowing to offload either full or larger portion of the IPsec flow, and then completely inline full line rate engines which can combine IPsec and MACsec in the same engine. As a spin-off of that development, we also have full line rate IPsec ESP transform engine as a foundation for building IPsec data path. So next slides will focus on inline full line rate engines and explain how IPsec is supposed to be built with these engines. So let's start with MACsec IP164. It's a multi-channel MACsec IPsec engine delivering from 100 gigabit to 800 gigabit aggregate line rate throughput. So we have multiple configurations optimized for aggregate throughput. This engine can support IPsec ESP tunnel and transport mode with ISGCM cipher suite and using local assays. So it can perform network header processing like updating IP and UDP headers. This engine can work either with bypass, MACsec, and IPsec modes on a channel basis. It means that if required, two different channels can use different modes. The principle of building IPsec flow is the following, that egress classification is done at system side, where there's a big tables for searching of flows or flow information is known. And then Silicon IP performs the IPsec transformation and completes the packet to be sent on the line. On ingress side, classification transformation is performed in Silicon IP, but only for the IPsec flow. It means that flow completion and firewalling functionality goes to the system side, which usually has already ACL database to filter the unwanted traffic. So this is in essence how IPsec is implemented in the MACsec engine, at the same time having full featured MACsec capability as well. Another IP, which is spin-off from the previous IP, is called Protocol IP67. It was developed to deliver full line rate ESP transform with ISGCM 128, 192, 256-bit cipher suite, and it also can perform ISGCM operations with a byte alignment. It has options for local and external assay, and it was used to build the IPsec data path either in firewalls or smart NICs in such ways that it does offload the full ESP transform operation, leaving network header processing classification up to customer to implement, which is usually already part of the smart NIC data flows. And if required, this engine can also be used to implement line rate ISGCM operations for other protocols like DTLS and TLS and whatever is needed. As a conclusion for this presentation, network security with MACsec and IPsec is being widely adopted within and between data centers. We see various types of devices supporting MACsec and IPsec with our IPs. The cost-effective solution is to integrate a feature-rich MACsec IPsec engine into the PHY or switch ASIC and give system vendors a choice to use the required security protocol depending on their goals. Rambus MACsec and IPsec IPs have been widely adopted by leading silicon and system vendors and provide the features and efficiency required for emerging trends in data center security. Thank you very much for listening to my presentation.